Okay, in this video we're going to look at multiples of 60 degrees on the unit circle. Okay, so let's just try to roughly draw that. Okay, so here's 180 degrees, and what we do is we take a third of that, and so that's breaking up the upper semicircle into three pieces. So you get 60 degrees, 120 degrees, so you 60 plus 60 is 120, plus 60 is 180. Then we get 240 degrees, and then 300 degrees. Okay, in another video, what we did, and then of course over here is 360 degrees, which is also 0 degrees. In another video, what we did is we made this 30, 60, 90 triangle, and we labeled it where the hypotenuse is 1, which corresponds to a unit circle. The problem with my picture here, it's not that much a problem, but I didn't use a very well drawn circle in many ways, so it's not really showing this that well. But opposite the lesser angle of 30 degrees is 1/2, and then opposite the larger angle is rad 3 over 2. So that fits in there nicely. So that means we're going to the right by 1/2 and up by rad 3 over 2. Now, if you look at this point here, what I'm trying to do is I'm going to try to find the x and y coordinates for these points also. I'm going to move to the left by the same amount, -1/2, as I move to the right for 60 degrees. I'm going to move to the left by 1/2, which makes it negative, and I move up by rad 3 over 2. X is negative over here in the second quadrant. So it's to the left of the y-axis, so we get negative. Now, also notice that the angle that's formed with 128 degrees and 180 degrees is 60 degrees. That's called the reference angle. So in fact, you can draw the same exact triangle and fill that in. Now, if you look at 240 degrees and subtract 180, you get 60 degrees. That also gives the same reference angle, and it gives us the same setup. So we get the same points here of 1/2 rad 3 over 2. But since we're going down, we're going to the left, so we have x is -1/2, and we're going down, so we have y is negative rad 3 over 2. And we use the same reasoning to get these points here. So notice multiples of 60 degrees are going to give us the same coordinates, but we're going to adjust for positive and negative. So we see that cosine of 60 degrees is equal to 1/2, and sine of 60 degrees is equal to rad 3 over 2. So cosine is the x coordinate, sine is the y coordinate. And if I look at, for example, well, I can just look at 120 degrees. I look at the x coordinate, and these are all going to be the same when I have these multiples of 60, so it's a little bit tedious to write this out, but I guess I will, because I can write sort of fast. And so there we go for that. Okay, now this is all in degrees, but I really want to use radians. It's more of my go-to thing to use is radians, because that's fits in with the natural world. We use that in calculus. Okay, so I'm going to really just draw the same picture here, but I'm going to use radians. So here's pi, and then I divide that into three pieces, and I get pi over 3. And I'm going to still have that same reference angle. And you know what, if you want, you can break down and write 60 degrees if you want, if that helps you, 60 degrees. But opposite the smaller angle is the shorter side. Opposite the larger angle is the longer side. And that informs us these numbers here. And then, see, this is 1/3, and we're going to get 2/3 pi. And I'm going to get the same coordinates. And by the way, look, 1/2 is the square root of 1 over 2, and rad 3 over 2 is the square root of 3 over 2. So square root of 3 is greater than 1. This rad 3 over 2 is a bigger number. So if you look at this, if you can see where 2/3 pi is, you can say, well, look, the amount I've gone to the left is less than the amount I've gone up. So this lesser number in magnitude, 1/2, is the x-coordinate. Okay, here's 2/3. This should go all the way through in a straight line. 2/3, this is 3/3 pi. Then we get to 4/3 pi. 5/3 pi, we're going to have the same coordinates, except we are going to adjust for positive and negative depending on the quadrant in which this lies. All of them have the same triangle with a 60-degree reference angle, or pi over 3 is your reference angle. All the same triangles. And so what we do is when we do a reference, to find the reference angles, we refer to the x-axis, not the y-axis. All right, so we can get these guys here, and this will tell us then what cosine of 4/3 pi is, or sine of 5/3 pi, and all those things.